This is my pre-algebra course. Today we're going to learn algebraic fractions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In the last class, we learned how to add, subtract, multiply, and divide variables, and we're going to use those principles in today's class to add, subtract, multiply, and divide fractions. So let's get started with number 1. We're going to add the following fractions, but we cannot add fractions unless we have a common denominator. We learned that in the last class, my arithmetic course. So I'm going to multiply both sides of this fraction by 7, and that will give us 7x over 56. And I'm going to multiply both sides of this fraction by 8 to get 24x over 56. So again, 7 times x is 7x. And 7 times 8 is 56. And 8 times 3x is 24x. And 8 times 7 is 56. This is what we learned in the last class, how to multiply algebraic expressions. So we're just multiplying these algebraic expressions by a constant. Alright, so now we have a common denominator, and we can just add the numerators. 7x plus 24x is 31x. And then we just rewrite the denominator, and that's our final answer. Alright, so number 2, I'm going to multiply both sides of, actually I can just keep this fraction, but I'm going to multiply both sides of this fraction by 2. So I'm going to go ahead and rewrite this fraction, multiply the other fraction, both sides of the other fraction by 2. And now we have a common denominator. 5y minus 4y is 1y, but I don't have to write the 1, I can just write y. So we get y over 6. Alright, now multiply both sides of this fraction by 3, and we get 3z over 12. And multiply both sides of this fraction by 2, and we get 10z over 12. And again, when you write a number next to a letter, that means multiplication. So 3z means 3 times z. That's what we did. We multiplied. And we're using the fundamental principle of fractions. We can multiply both sides of a fraction by the same number, and it doesn't change the value of the fraction. So now 3z minus 10z is negative 7z. And of course, we just rewrite the denominator. So this is much like the previous classes and the previous classes in the previous course, in the sense that we need a common denominator when we add or subtract fractions. The same is true for algebra. Alright, we're going to multiply both sides of this fraction by 3 to get negative 9x over 24. And don't worry, you're going to try some of these on your own, but we're going to do some more together first. Multiply both sides of this fraction by 2 and you get 10x over 24. Alright, negative 9x plus 10x is 1x. And so we get x over 24. Alright, I'm going to multiply both sides of this fraction by 2 to get 10y over 18. And both sides of the other fraction by 3. And now I have a common denominator. So 10y plus 3y is 7y. And then just rewrite the denominator. Alright, number 6. I'm going to multiply both sides of this fraction by 6. And both sides of the other fraction by 5. And now we have a common denominator. And negative 12z plus negative 5z would be negative 17z. So we get negative 17z over 30. So again, we'll just try maybe 3 or 4 more of these together till you get the hang of it, and then you can try some on your own. Now this is the condensed notation that students really dislike. We're going to multiply both sides of this fraction by 3, and we get negative 9a over 24. Multiply both sides of this fraction by 2, and you get 10a over 12. Wait a second, that was not correct. Multiply both sides of this fraction by 4. That's what we want, 4. Now we get 24. All right, so negative 9a minus 20a. See if you can figure out what that would be. Negative 9a minus 20a. Is it going to be 11? Is it going to be negative 11? Is it going to be 29 or negative 29? Which one is it going to be? Well, if you said negative 29a, you were correct. And we cannot reduce that. All right, so now we have a situation that's a little bit different because we have what you can consider a whole number, or it looks like a whole number. So what we're going to do is we're going to rewrite this. And whenever you have a whole number, you can always write it as over 1. Remember that? For example, if you're going to add 7 plus 2/3, you can write the 7 as over 1, and then it just becomes a standard fraction problem where you have to get a common denominator, and we can just move that up like that. So you multiply both sides of this fraction by 3, and you get 21 over 3, and now we have a common denominator. 21 over 3 plus 2 over 3 is 23 over 3. So that's how we would do it in a previous class in some contexts. Or we would just change it to a mixed number. But in algebra, we're not going to use mixed numbers, so we're going to just write it in this form. And so we're going to multiply both sides of this fraction by 3 to get 15b over 3 plus 2b over 3. And now we're ready to add because we have a common denominator. So we get 17b over 3. And I know that looks like an improper fraction, but we don't really care at this point. In algebra, we don't really care much about improper fractions. All right, so we're going to do a couple more, and then you can try some on your own. Actually, you know what? You might as well just try this one, because we have a double negative. You can deal with double negatives. You know what to do there. So try number 9, and when you come back, we'll do it together. All right, we're back. So I'm going to change the double negative to a positive. And now I'm going to multiply both sides of this fraction by 11. And both sides of the other fraction by 7. And now you can see we have a common denominator. Add those up. 33y plus 35y is 68y, I believe. And rectangle that. All right, so if you got 68y over 77, good job. Now try another double negative problem, and when you come back, we'll do it together. All right, we're back. So negative, we'll just rewrite this fraction, and then the double negative becomes a positive. Remember, this negative does not change. That has nothing to do with these negatives over here. These are double negatives. This is not a double negative. So this negative stays, but these negatives become a positive. All right, so multiply both sides of this fraction by 3 to get a common denominator. And then negative 3z plus 5z is 2z. But this is a special case because sometimes you can reduce these fractions. So 2z over 6, that reduces. You can divide both these numbers by 2, and then it becomes 2 divided by 2 is just 1. and 6 divided by 2 is 3. But we don't write a 1 next to the z. It's just traditional to just leave that 1 off. So if you got z over 3, good job. If you got 2z over 6, you're correct, but you just have to reduce that. All right, number 11. So now it's time for you to go into this full on now. Attempt number 11. When you come back, we'll do it together. All right, we're back. We're going to multiply both sides of the first fraction by 9 and both sides of the second fraction by 5. And then we have a common denominator. So 18x plus 20x is 38x. And I don't think we can reduce that, so that's our answer, 38x over 45. If you got that answer, good job. All right, number 12, go and attempt that one, and when you come back, we'll do it together. All right, we're back. We're going to rewrite this fraction, multiply the other fraction, both sides of the other fraction by 2, and then subtract, and you get y over 10. So if you got y over 10, good job. All right, pause the video, try number 13, and when you come back, we'll do it together. All right, multiply both sides of the first fraction by 6. Multiply both sides of the other fraction by 5. And now we have a common denominator. 18a minus 25a is negative 7a. And feel free to skip forward if you don't want to see the explanation. You just want to figure out if you did if you got the right answer. You can use the right and left arrow keys and the L and J keys to skip forward and reverse. All right, number 14. Attempt number 14, and when you come back, we'll do it together. All right, we're back. Multiply both sides of the first fraction by 3. Multiply both sides of the second fraction by 2. And again, that's the fundamental principle of fractions. And negative 9b plus 10b is a 1b, but we don't write the 1 there. We don't need that 1. We just write b. It's crucial for you to understand that b is just the same thing as 1b. So we get b over 12. If you got b over 12, good job. If you didn't get b over 12, that's okay. Just go back and figure out what you did wrong. All right, on to number 15. Attempt number 15, and when you come back, we'll do it together. All right, we're back. Multiply both sides of the first fraction by 5. And multiply both sides of the other fraction by 2. And now we have a common denominator. 15c plus negative 2c is 13c. And there you go. So if you got 13c, good job. Try number 16, and when you come back, we'll do it together. All right, we're back. Multiply both sides of the first fraction by 4. And both sides of the second fraction by 5. And now you can see we have a common denominator. Negative 28x plus negative 25x. Let's see, that would be negative 53x. So if you got negative 53x over 40, good job. Try number 17, and when you come back, we'll do it together. All right, we're back. All right. And this is the condensed form. This is the form where students get really frustrated because you have the two negatives together where it's condensed here, no parentheses or plus signs up here. All right, so actually that was incorrect. That shouldn't be 56. That should be 61. So negative 61a over 56. If you got that one correct, good job. That was a challenge problem because we had the condensed notation. All right, now 18 is a different problem because we have what looks to be some sort of a whole number term. We don't have any fraction there. But remember, for this one, you have to rewrite the problem, and then you have to write 2b over 1 so it becomes a fraction. Then it just becomes the same type of problem that we've been doing before. You get a common denominator. So attempt number 18, and when you come back, we'll do it together. All right, we're back. So we're going to multiply both sides of this fraction by 5, but we'll rewrite the other fraction first. And then we multiply both sides, we get 10b over 5. And now we have a common denominator. So 3b minus 10b is negative 7b. And just rewrite the denominator. So if you got negative 7b over 5, good job. I'm proud of you. All right, so on to number 19. Now we go to double negatives. Try 19, and when you come back, we'll do it together. All right, we're back. You know what? I'm going to take it step by step. I'm sorry about that. I get rid of the double negative first, just to take things slow. So we get rid of the double negative. And 28z plus 18z, that'd be 46z over 63. And I do not think that we can reduce that. So if you got 46z over 63, good job. All right, try number 20. When you come back, we'll do it together. All right, we're back. So I'm going to get rid of the double negative. Again, this negative has nothing to do with the double negative. This negative does not go away. Only these negatives go away because they're right next to each other. They turn into a positive sign. All right. Get a common denominator. And negative 3a plus 4a is 1a. So if you got a over 18, good job. All right. Go into attempt 21, and when you come back, we'll do it together. All right, we're back. Now, in case you forgot, if you multiply 10 by 10, you get 100. So I multiplied the first fraction. I multiplied both sides of the first fraction. You have to be careful about the way you say it. We're not really multiplying the fraction by 10. We're multiplying both sides by 10. That's very different. So I multiplied both sides by 10, and I got 30 over 100, 30x over 100. So now we have a common denominator. Add them up, and there you go. All right, so now we're going to do some more of those fraction problems. But the difference, well, let me shrink this stuff, get it kind of out of the way there. Getting kind of cramped here. The difference with these problems is now we have more than two fractions that we're adding up. But it's really just the same situation. So we'll do a couple together, then you can try some on your own. So it looks like the common denominator for all these fractions is going to be 44. So I have to multiply the second fraction by 4. Multiply both sides by 4, that is. And the third fraction, I have to multiply both sides by 2. And now we're ready. 5x minus 12x is negative 7x. And negative 7x plus 14x is 7x. And that's our final answer. All right. Number 23. Looks like our common denominator is going to be 56. Let me rewrite that denominator there. And it looks like we have a double negative. So I'm going to go ahead and rewrite that. First step is we get rid of that double negative. Then we get a common denominator. So now we have a common denominator. Negative 40y plus 21y is negative 19y. Negative 19y plus 11y is negative 8y. All right, and looks like we can reduce this. If we divide both sides of this fraction by 8, 8 divided by 8 is 1, and 56 divided by 8 is 7. So our final answer would be negative y over 7. All right, number 24. 24 is a little different because we have the condensed notation. But all we're doing is just adding all these fractions up. They're all negatives and we're adding them all up. So why don't you go ahead and try 24, and when you're done, we'll do it together. All right, we're back. So I multiplied both sides of the first fraction by 6. And I kept this fraction the way it is, and both sides of the last fraction by 2. And now we have a common denominator. So again, this is just asking us to add up a bunch of negative numbers. I know it doesn't look like that, but that's what it's doing. It's the condensed notation. So 12z plus 5z is 17z, and 17z plus 14z is, I think, 31, negative 31z. And we cannot reduce that, so that would be our answer. So if you got negative 31z over 18, good job. All right, why don't you try number 25, and when you come back, we'll do it together. All right, we're back. So it looks like 30 is going to be our common denominator. Looks like we're going to end up with negative 2x over 30. But negative 2x over 30 can be reduced. divide 2 by 2 and you get 1, and divide 30 by 2 and you get 15. So again, we don't write the 1 there. And again, to remind you, you can put the negative next to the x where it is now, or you can put the negative over here, and technically it's not incorrect to put it down here. But the best place is probably right in front. But the problem with putting it in front is, like I said before, it kind of sometimes bleeds into the fraction, so it might be better to just put it there. It doesn't really matter, to be honest with you. All right. But the traditional location is right in front of the fraction line, or level with the fraction line. So why don't you try 26? We've got condensed notation here, so be careful. And when you're done, we'll do it together. All right, we're back. It looks like 24 is going to be the lowest common denominator. All right, so negative 15y minus 6y is negative 21y. Negative 21y plus negative 20y is negative 41y. And we cannot reduce that. So if you got negative 41y over 24, good job. All right, number 27, we have a number that appears to be a whole number, so you're going to have to write that as over 1, and then find a common denominator. So go ahead and attempt 27, and when you come back, we'll do it together. All right, we're back, so we're going to multiply both sides of this fraction by 6. Both sides of this fraction by 2. And we're just going to leave the other fraction. So now we have a common denominator. Negative 24a minus 4a is negative 28a. And negative 28a plus a. Now this is not 0 a's, that's 1a, so that would be negative 27a over 6. Now we have a slight problem here because this is not reduced. So I'm going to have to shrink this stuff because I'm running out of room here. And if we divide both sides of this fraction by 3, 27 divided by 3 is 9. And 6 divided by 3 is 2. So that's our final answer. So if you got negative 9a over 2, good job. So moving right along here. Why don't you try 28? When you come back, we'll do it together. All right, we're back. So we have negative 3x over 1. We're going to change it to a fraction. Even though it doesn't look like a fraction, we can make it look like a fraction. And then we're going to multiply both sides of the first fraction by 6. Both sides of the second fraction by 2. This seems almost exactly like the previous problem that we did. I guess that's just a huge coincidence. It's almost exactly the same as the previous problem we did. All right, so now we just add those problems. Negative 18x plus 4x is negative 14x. Negative 14x plus x is negative 13x. So we got negative 13x over 6. Good job. All right, on to number 29. Try 29, and when you come back, we'll do it together. All right, we're back. We're going to multiply both sides of the first fraction by 2. And both sides of the second fraction we can just leave it. And both sides of the last fraction by 3. And 2b minus 5b is negative 3b. Negative 3b plus 9b is 6b. And 6 over 12 reduces to 1/2. But instead of writing the 1, we just write the b. So if you got b over 2, good job. Go ahead and try number 30, and when you come back, we'll do it together. All right, we're back. We're going to multiply both sides of the first fraction by 5. And the second fraction by 6. And this is a double negative, so I'm just going to go ahead and write that as a positive. And multiply both sides of that fraction by 3. And so then we can add those up. Negative 25c plus 18c is negative 7c. Negative 7c plus 33c is 26c. Yep, looks like that's correct. And then now we can reduce that fraction, divide both sides by 2, and we get 13c over 15, which is not our those are not our multiplication facts, but you can figure that out. So if you got 13c over 15c, good job. All right, try number 31, and when you come back, we'll do it together. All right, we're back. So this is the condensed form of the notation. And we come up with the following. So now we can just add those together. Negative 35 minus 32, that would be negative 67. And negative 67 minus 18 would be negative 85 x over 40. Now this can be reduced, and it looks like it can be reduced by 5. And you can use a calculator for this, but I don't have my calculator handy, so I'm just going to divide 85 by 5. And it looks like it goes in 17 times. So divide both of those numbers by 5, and we get negative 17x over 8. So if you got negative 17x over 8, good job. If you got negative 85x over 40, that's fine too. You just have to reduce it. All right, on to number 32. Attempt 32, and when you come back, we'll do it together. All right, we're back. So I multiplied the first fraction, both sides of the first fraction by 2. And I'm going to write r over 1. And then I'm going to multiply both sides of this fraction by 8 to get negative 8r over 8. And I can just rewrite the other fractions. (6r plus 4r is 10r, and 10r minus 8r is 2r. So you get 2r over 8, but that can be reduced. Divide 2 by 2, and you get 1. and divide 8 by 2 and you get 4. So again, I'm not writing the 1 next to the r, because whenever you have a variable, you don't have to write the coefficient if it's the number 1. So if you got r over 4, good job. Try number 33. When you come back, we'll do it together. All right, we're back. I'm going to write 2a over 1. And I'm going to change the double negative to a positive. Then I'm going to multiply both sides of the first fraction by 8. And I'm going to keep the second fraction the way it is. I'm going to multiply both sides of the third fraction by 2. And we get 16a minus 5a is 11a. And 11a plus 2a is 13a. So if you got 13a over 8, good job. So that was adding and subtracting fractions. So now we're going to practice. We're going to do some decimals. So we learned how to add and subtract and multiply and divide negative decimals in one of the previous classes, but now we have variables added onto these, but it's pretty much the same operation. So we can use our calculator, because the purpose of this class is not to teach you the arithmetic algorithms that you learned in the previous course. The purpose of this class is just to teach you the basics of algebra. So we can just use our calculator and we can do 3.2 minus 5.6, and we get negative 2.4x. So we know that it has to be negative because this number is bigger and you're subtracting it. And so we know it's going to be, they're opposite signs, so they're going to fight against each other, but we just have to figure out how far apart these numbers are, and that's exactly what we did. So now we have two negatives for number 35, and we're adding those two negatives up. So if you use your calculator, 12.9 plus 4, you'll get 16.9. And we know it has to be a negative because we're adding two negatives. And you just add your y onto there. All right. So now the next problem. Again, you can use your calculator. This is the condensed form of adding two negative numbers. So I'm going to use my calculator. And I get 7.22. I just added those numbers together, and then you just add a negative there because they're negative. So as you can see, adding and subtracting decimals is pretty easy, but you have to know whether or not you're subtracting or adding the numbers. And that's not always obvious. So that's the purpose of this course, is to teach you fluency in the notation, and to teach you what to do when you see these types of notations. Do you add? Do you subtract? Do you multiply? Do you divide? All right, so we know that our answer for number 37 has to be negative because the negative defeats the positive. We just need to figure out by how much it defeats. So 8.9 minus 6.2. We're just trying to figure out the difference between those two numbers, so we subtract. Now, in case you're wondering, you can do that in your calculator. The way that you would punch those numbers in is you would put 6.2 and then you would put plus 8.9, but then you push the little plus negative sign. You have a positive or negative sign, you push that, and then you push equal and you get negative 2.7. So you can do it that way also. But the purpose of this class really isn't to tell you how to enter stuff into your calculator. That's not the point. The point is you want to know, is the answer going to be negative or positive? And do you add these two negatives or do you subtract those? Do you add these two numbers or do you subtract them? All right, so number 38, we're going to add those two numbers because they are both negative. And we get negative 16.5z. So those are some examples. And now it's your turn. Why don't you try number 39, and when you come back, we'll do it together. All right, we're back. If you said negative 3.9x, good job. All right, attempt number 40. When you come back, we'll do it together. All right, we're back. So I'm going to have to get out my calculator for that one. And I got 12.13. Now you just add the negative and put your x at the end. So if you got negative 12.13x, good job. All right, and 41, we have the same exact situation, except it's the condensed notation. So attempt 41, and when you come back, we'll do it together. All right, we're back. If you figured out that it's just going to be the same answer as the previous problem, you were correct. It's just a condensed notation. All right, number 42. Go and attempt that problem, and when you come back, we'll do it together. All right, we're back. Looks like we're going to get 0.3y. If you got 0.3y, good job. All right, number 43, go and attempt that problem. When you come back, we'll do it together. All right, we're back. So we have a positive and we have a negative. So we're going to have to subtract. And I'm using my calculator, and I got 97.327. 97.327. I don't have to put my z at the end there, so I'll move that over. And then the answer is going to be positive because this number, the positive, is much bigger than the negative. So if you got that answer, good job. All right. On to number 44. So now we're going to multiply and divide. In all the previous problems, we were just adding or subtracting. So notice the parentheses. Parentheses means multiplication. And I know what you're thinking. You're thinking, well, wait a second. Didn't we have parentheses in the previous problems? We have parentheses here. Doesn't this mean multiplication? Well, it actually does, but you don't have a parentheses right next to the other number. If your parentheses are right next to the other number, then it's multiplication. You could interpret it as multiplying this number by a positive 1. But I know that gets kind of confusing. You'll figure that out later as we go. But if your parentheses are right next to this number, then you're multiplying. But if your parentheses are right next to an addition sign, then you're just multiplying this fraction by positive 1. And in that case, you just get the same answer. But I know that's kind of confusing to think about. But just know that if you have numbers right next to each other, and the only thing between them is parentheses, there's nothing in between here, no plus or minus sign, then you know it must be multiplication. I know that's kind of confusing, but again, this is the whole purpose of this course, is for you to learn fluency in algebra. So now we know that this has to be multiplication. So the big question is simply this: how do we multiply fractions? Well, we learned in the previous course that to multiply fractions, you just multiply the numerators straight across, and you multiply the denominators straight across. So that's what we do. So we learned how to multiply algebraic expressions in the last course. So let's do the easy part first, though. Let's do 7 times 6 is 42. And then we have a negative times a positive. We learned that when you're multiplying and dividing, you use that cheesy story. A negative and a positive are unlike signs. They don't like each other, so it's a negative situation. So you put a negative. So now we just have to figure out the hard part. That's multiplying the numerators. So again, in the previous class, we learned if you multiply algebraic expressions, you multiply the numbers first. So 3 times 5 is 15. And x to the second power times x to the 8th power, you just add the powers. And we get x to the 10th power. And unfortunately, we're not done at that point because we have to reduce. Now it's not going to be that easy to reduce because we have multiplication that is not part of our multiplication facts. So, but it is going to be 3. So what we're going to have to do is we're going to have to go backwards, and we're going to have to factor the 15 to 3 times 5, and the 42 to 6 times 7. So notice that we're just going the exact opposite direction to factor these, which is really counterproductive. And I'm going to tell you a faster way to do this as we go along. So I'm going to further factor the 6 into 2 times 3. And then you can see that the 3's are going to cancel out. And we're going to end up with, our final answer is 5x to the 10th over 2 times 7. And 2 times 7 is just 14. So that's our final answer. 5x to the 10th power over 14. And x to the 10th power just means x times x times x times x 10 times. All right. And I just noticed I forgot my negative sign. It's very easy to forget your negative signs. All right. So again, I'm going to teach you an easier way to do it, because obviously you don't want to go in the forward direction and then have to go backwards and then reduce. So I'm going to teach you an easier way, but I don't want to redo that problem. So let's just go on to the next one. So again, we're going to multiply the numerators and the denominators. So 2 times 5 is 10, and a to the second power times a to the fourth power, you just add the powers, so you get a to the sixth power. And then a positive times a negative is a negative, so I'm going to go ahead and put my negative before I forget. And 3 times 9 is 27. And b to the third power times b to the first power is b to the fourth power. And in that problem, we actually do not have to reduce. So that problem was a lot easier than the previous problem because we did not have to reduce. But I didn't get an opportunity to show you the other method for reducing. All right, on to number 46. So 46 is much like the above problem. Negative 2 times 5 is negative 10. And c squared times d to the fourth. We can't really combine those because they're different numbers. So we'll just put them next to each other. So this is different from the other problems because we have to put letters next to each other. And 3 times 9 in the bottom is 27. And then d times c to the third. Again, those are not different numbers, so we just have to put them next to each other. But in this problem, instead of reducing the numbers, as we did up here, we have to reduce the letters. Now again, this is something that you learned in the previous class. So what we're doing here is, remember the fraction symbol is the same thing as division. So first of all, we're just going to rewrite the 10 and the 27 because we can't really do anything to those. But we have a c in the top and the c in the bottom, so we're dividing those, so that means we're going to subtract the powers. So there are more c's on top, So the c that is left over is going to be on the top. So 2 minus 1 is 1. So we have c to the first power. But again, we don't write 1 in the power. We can just write it as c. All right, and we have d to the fourth power over d. So we're going to subtract 4d's minus 1d is 3d's. And there are more d's in the top, so we're going to write those 3d's in the top, in the numerator. All right, so again, I know this is all new to you, but you're going to get the hang of this as we go along here. So in the next problem, I'm going to have an opportunity to do to show you a lot of different things here. But let's see here. I'm going to go ahead and keep it in factored form. There's a lot of different ways that we could do this. But I see a 12 here and I see a 2 here. And you know, the 2's on top and the 12's on the bottom. And both 2 and 12 have common factors. So I know that those are going to reduce. So I could just go ahead and cross them out and divide both of those numbers by 2 to get 1 and 6. That's the fastest way to do it. But that's really not a good way to do it, because notice if I just start crossing stuff out, then I can't see my original problem. Never, 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 never do that. Students love to do that because it's easy. But then if you go back and you try to look at this problem to review for your test, you can't see the original problem. And I, as your teacher, cannot see the original problem, so I can't make sure that you actually did it. And if you're in school and you want to turn in your homework and your original problem has a bunch of scribble on it, then your teacher is really not going to like that. Your teacher wants to see a record, a very clear record of your work. And that's the way it is in high school and college, if you're going to go to a good high school. All right, so I'm going to just leave those numbers in factored form. 2 times 5. And we have x squared times, there's no other x's in the numerators. And again, we're just multiplying the numerators straight across. And we have y to the 9th times y to the 6th, which would be y to the 15th. And z to the 6th, there's no other z's. And we have a negative times a negative, so that would be positive. And we have 7 times 12. Now we're going to multiply the denominators. So 7 times 12, I'm just going to leave that in the factored form. And we have z squared times x to the 8th. So those are not the same letters, so we have to write them. We can't combine them. So that's what we end up with. But there's a lot of reducing that we can do here. So I'm going to factor. I'm going to factor the 12 to 2 times 6. And the x squared, we have an x squared here and an x to the 8th. So we have to subtract those. And you end up with 6, but there's more x's in the bottom, so the x's are going to end up in the bottom, x to the 6th power. And the y's, we've already combined the y's, so we have y to the 15th. But we have 6 z's in the top and 2 z's in the bottom, so we subtract, we get 4 z's, and the z's are going to be on the top because there's more z's in the top than on the bottom. And also, I'm going to cancel out these 2's. So we're going to end up with 5 y to the 14th z to the 4th over 7 times 6. We're going to go ahead and combine these two. You get 42. And then we have the x to the 6th power. So as you can see, there's quite a bit of stuff going on there. But you'll get the hang of this as we go along. All right, let's try number 48. 5 times nothing. Well, it's not really nothing. It's 1. 5 times 1 is 5. And negative times a negative is a positive. And 7 times 2 is 14. And again, when you multiply fractions, you're just multiplying the numerators and multiplying the denominators. So your product of the numerators goes here, and your product of the denominators goes here. 7 times 2 is 14. And then we have a up here, and b to the 3rd power times b is b to the 4th power. Then we get c to the 7th power. And in the bottom, we just rewrite those letters here. C to the 5th power and a to the 2nd power, but then we have to reduce the result. So 5 over 14 we can't do much with. But the a's, we have 1a in the top and 1 in the bottom. So we subtract 2 minus 1 is 1, and then there are more a's in the bottom than the top, so we just write the a in the bottom. And b to the 4th, that no more b's. C to the 7th over c to the 5th would be c to the 2nd power. And there you go. Because there's more c's in the top than on the bottom, so when you subtract and you get 2 c's, 7 minus 5, you get 2, that 2 goes in the top. Alright, so now we have something a little different. We have what appears to be some sort of a whole number term. So we're going to change that to a fraction. And then we're just going to multiply like we normally do. Alright, so multiply the numerators, just like the other problems. 3 times 2 is 6. And I know our answer is going to be negative, because a negative times a positive is a negative. E to the 2nd times e to the 3rd is e to the 5th. And 5 times 1 is 5. And it looks like that's going to be our final answer. So that's what you do if you have a whole number. You just write over 1. So this is another example of that. We're going to write that as over 1. Because this looks like a whole number term. And then we just multiply 3 times negative 4w to the 7th is negative 12w to the 7th. And 5w to the 2nd times 1 is 5w to the 2nd. And the negative 12 and the 5, we can't really do much with that. But the w's, we can combine those. So you're dividing. Remember, the fraction sign means division, so you subtract the powers. 7 minus 2 is 5, and there's more w's in the top than the bottom, so the 5 w's go on the top. All right. Whoops, I forgot to rectangle that. So now we're going to do division. Now I know what you're thinking. You're thinking, wait a second, I didn't try any problems myself. Well, we're going to get to those later on. But division is much like multiplication, so we're going to go ahead and do the division problems together. And then you're going to try both the multiplication and division problems on your own. But let's do some division together first. All right, so for division, I'm going to change to a smaller pencil here. So what we do for division is we, remember, we learned in the last course that you change the division sign to multiplication and you flip the divisor. So we're going to go ahead and write the dividend. Just rewrite that. Change the division sign to multiplication, but in algebra we don't use a cross for multiplication. We just put parentheses. Now, we have parentheses here, but that doesn't mean multiplication because the parentheses are next to a division sign. The only reason we wrote these parentheses is we have a negative here, and it's not traditional to write a division sign next to a negative. So that's the only reason we wrote the parentheses there. But if you write the parentheses without a division sign or a multiplication sign or any kind of plus or negative sign, then that means multiplication. So we're changing this to multiplication, and we're flipping the divisor. So we change to multiplication, and we flip the divisor. So now the problem just reduces to the same type of problem that we were doing previously, and now it's just a multiplication problem. So with division, you just have one more step. You just do that step that we just did there. Well, technically it's 2 steps, and then now you have a multiplication problem. So now we're going to multiply the numerator straight across. And then we get 32. X to the second times x to the fifth is x to the seventh. You're multiplying those, so you add the powers. Don't confuse that. When you're multiplying straight across, you add the powers, but when you're reducing, you have w's on the top and the bottom, then you subtract the powers. So there's a lot going on here. All right, and then we just rewrite the y to the fifth. And 5 times 3y to the third is 15y to the third. But it looks like we have some y's that we can combine. So we have y's on the top and the bottom, so we're subtracting the powers. And actually I forgot the negative there, so I put that negative there. Again, it doesn't matter where you put it as long as it's somewhere in front. So we got 32 over 15, x to the seventh, and we're going to subtract the powers for the y's, so we get y to the second, and it goes in the top because there's more y's on the top than on the bottom. So those two y's that we got after subtracting go on the top. All right. So now let's try another one of those problems. So again, when you're dividing, you just rewrite the dividend. And then flip the divisor and change to multiplication. All right. So now it's a multiplication problem. We just multiply the numerator straight across. So now this is where I can demonstrate something really important here. If we multiply, we're going to get 30 over 36, but that can be reduced. So it doesn't make sense to get 30 over 36 and then try to factor again. We don't really need to factor on that one because we know that 6 times 5 is 30 and 6 times 6 is 36. But it's a lot easier to just use something called cross-canceling. So we have a 3 on the top and a 9 on the bottom. So I know that 3 goes into both those numbers. So when you have numbers on the top and the bottom that have common factors, you can go ahead and just divide those numbers by those common factors. So I'm going to divide 3 by 3 and I'm going to get 1. And I'm going to divide 9 by 3 and I'm going to get 3. So you're dividing both those numbers by the same number. So now I also know that 10 and 4 have common factors, and one's on the top and one's on the bottom. Again, this does not work when you're going straight across. It only works when one's on top and one's on the bottom. Another important point is that if you have one on top here and one on the bottom here, you can also do that method. You can also reduce. But we've already learned that. So I know I can divide both the blue numbers by 2. So I divide 10 by 2, I get 5. I divide 4 by 2, I get 2. So you're probably thinking, well, why did we just do that? Well, it just makes it so that we can find the answer a lot quicker because now we use these numbers to multiply across. And we're not going to have to reduce later on. So 1 times 5 is 5, and 2, so that's 1 times 5 is 5, and 2 times 3 is 6. So now we have a completely reduced fraction when it comes to the numbers, that is. 3 and 2. So now we just have to deal with the letters. So s to the 4th power times s to the 6th power is s to the 10th power. And we have r to the 4th. And then h to the 1st power times h to the 2nd power is h to the 3rd power. And we have r to the 2nd power. Now that cross-canceling method actually works for the letters also. I'm not using it for the letters right now, but it does work for the letters. We have an r in the top and the r in the bottom. So we can cancel, and I don't think we can cancel anything else. So you could do that, but if you do that, it starts to get messy because you have to. Well, I guess I don't have to cross, but you don't really have highlighters, so And even if you did have highlighters, I wouldn't want you to use them because it's going to mess up your paper. Highlighters are kind of hard on paper. It's going to bleed through to the other side of your paper. So you'd have to cross out. But when you start crossing out, things start to get really messy. When you're dealing with powers, when you're dealing with regular numbers, it's okay to cross out because you can kind of still see the number. But with powers, it's going to get messy. So I'm just going to leave it in this form. At least I'm going to use that form as an intermediate step. And now we can just combine those r's, and I should have a negative in front of here. Don't forget that negative. So we're dividing those r's because he has a fraction sign. One's on top, one's on the bottom. So we're going to subtract 4 minus 2 is 2. And the 2 r's are going to be in the top because there's more r's in the top than in the bottom. And don't forget that negative sign. Put that right there. So that's the final answer. All right. We're going to have to speed up here a little bit. These division problems take a while to explain. We don't want to run out of time. So now we're dividing two negatives. So our answer is going to be a positive. And I flipped and I changed the multiplication. So now we're ready to go. Doesn't look like we can do any cross canceling because I don't have any numbers that have common factors in the top and the bottom. Multiply straight across. And that's what we get. So we cannot reduce 45 over 22, so we just rewrite that. The A's have already been completely combined. The C's have been completely combined, but the B's need to be combined. So we'd end up with 1B in the bottom. Again, 4 minus 3 is 1, so there's 1B, but there's more B's on the bottom than the top, so the B ends up on the bottom. All right, on to number 54, and again, I'm going to give you a chance to do these on your own, but we're going to do more of these together because this is quite involved here. And I'm going to start going a little faster here because I don't want to bore you. And I don't really need those parentheses on that one. All right. Everything looks right. So we're multiplying two negatives, so we're going to get a positive. And I know that I can cross these out because 10 and 8 are on the top and the bottom, and they have a common factor. We can divide both those by 2, and we get 5 and 4. Then we multiply straight across. 5 times 7 is 35. 4 times 9 is 36. X to the 6th, y, and we get a y in the bottom. All right, so now those y's, if you'll notice, those y's have the same power, so they just go away. First power and first power, the y's just disappear. So that's our final answer on that one. On to number 55, and we're almost there. We've got to do 2 more of these problems before you try some on your own. Whenever it's a complex process, we got to do a few more than we usually do on together. Actually, we're not doing a larger number. It just seems like that because these are longer problems. So now we have what looks to be a whole number term. So we just write that over 1. Change to multiplication, flip the divisor. And we're ready to go. So we have a positive and a negative, so we're going to get a negative. And 7 times 4 is 28, no cross-canceling. There's no terms on the top and the bottom that have the same factor. H is combined to the 6th power, g to the 7th, and g to the 5th. That g to the 5th should probably be written a little closer. All right. Let's see here. Everything looks right. All right, so the only thing we can do is just combine those g's. And once we're done with that, we'll have our answer. All right, so we have 7 g's multiplied together and 5 g's multiplied together. So we have to subtract. 7 minus 5 is 2. And there's more g's on the top, so we're going to put those 2 g's in the top. And that's our answer. All right, we'll do one more of these together before you try some on your own. Again, we have another term that looks like a whole number term. The reason that I say it looks like a whole number term is because d can actually be a fraction. So technically, we don't know for sure it's a whole number. It just looks like a whole number term. All right, so I'm going to go ahead and rewrite that. In the previous problem, we did 2 steps at once, but I'm going to go ahead and show both steps here. So I'm going to write that as over 1. So all I did was just change the divisor so that it looks like a fraction. I wrote it over 1, negative 3d to the 8th power over 1. So now, I'm going to flip the divisor and change to multiplication. And so we just multiply straight across. 5d squared times 1 is 5d squared. And 6 times negative 3, 8 to the 8th is negative 18 d to the 8th. Now we just have to reduce those 8s. The d's. 8 minus 2 is 6, and there's more d's in the bottom than on the top, so those 6 d's go on the bottom. All right, so I know that that's a very complex process there, but that's just the name of the game today. This class is going to be a little more difficult because of these multiplication and division problems with fractions, but you're becoming an algebraic master at this point. So why don't you try number 57, and when you come back, we'll do it together. All right, we're back. So multiply those numerators together, and you get negative 8e to the 6th. Multiply the denominators, and you get 25. So that one was a pretty easy problem. We started off with an easy one there. Why don't you try 58? And when you come back, we'll do it together. When you do 58, actually, I was going to say there might be canceling, but it doesn't look like there's going to be canceling. So try 58. When you come back, we'll do it together. All right, we're back. So our answer is going to be negative. Multiply straight across. And we get 72 in the bottom. b to the 4th. So there was no cross-canceling or anything that we needed to do on that one. So if you got that answer, good job. Again, when you're multiplying, you multiply straight across, and you add the powers of the letters. And a negative times a positive is a negative. All right, so try 59, and when you come back, we'll do it together. This one, you have to you're going to have to reduce. You're not going to have to reduce these numbers because we don't have any numbers that are on the top and the bottom that have common factors. But you are going to have x's in the top and the bottom, so you're going to have to reduce those at the end. When you come back, we'll do it together. All right, we're back. So a negative times a positive is a negative, so our answer is going to be negative. 3 times 5 is 15, and 4 times 7 is 28. Y to the 5th power times x to the 2nd power, we cannot combine those. And x times y to the 2nd power is just x times y to the 2nd power. But now we have to reduce. So we'll go ahead and rewrite the 15 and the 28. And 5 minus 2 is 3, so we have 3 y's on the top. And 2 minus 1 is 1, so we have 1x on the top. So if you got 15y to the 3rd power times x over 28, good job. And by the way, I said 15y to the 3rd power times x. Technically, it would be 15 times y to the 3rd power times x. But anyway, you get the point. All right, for number 60, we're going to be able to cancel these, the 2 and the 12. But we don't really want to start crossing them out immediately because that would mess up the original problem. So the best way to do it is probably to keep it in factored form. Negative times a negative is a positive. So we're going to have a positive fraction, then we'll just keep it 2 times 5 over 9 times 12. All right. And just write our r's and our s's. All right. So we end up with that. All right, so now we're just going to have to reduce this algebraic fraction. So the top is factored 2 times 5, and then we'll just we'll factor the 12 to 2 times 6. We could factor the 9 and the 6 further, but we don't really need to because we know we're just looking for that 2. We cancel out those 2's. And r is 2 minus 4, or excuse me, 4 minus 2 is 2, and the r's end up in the bottom. And the s's end up in the top, 4 of them. 6 minus 2 is 4. And the h's end up in the bottom because there's no other h's to combine. So our final answer is going to be 5s to the 4th power over, we're going to combine 9 and 6 to 54. And then we're just going to rewrite the letters. So that was kind of a long one there. All right, so now let's try 61. Go ahead and try 61, and when you come back, we'll do it together. All right, we're back. Negative times a negative is a positive. 4 times 1 is 4. 7 times 1 is 7. A to the 3rd power, b to the 7th, and c to the 7th power, a to the 3rd power. So you can see those a's have the same power, so they're just going to cancel out. So we end up with 4b to the 7th power over 7c to the 7th power. So if you got that answer, good job. All right, try number 62, and when you come back, we'll do it together. All right, we're back. So notice we have a term that looks like a whole number term. So we're just going to write that over 1. And we're going to multiply straight across. So if you got that answer, good job. All right. Try number 63. And when you come back, we'll do it together. All right, we're back. We have a number that looks like a whole number, or a term that looks like a whole number, so we're going to write over 1. Now you just multiply straight across like you normally multiply fractions. And we're just going to keep it negative 12 over 5. We can't really reduce that, but the w's reduce. There's more w's in the top than the bottom, so the difference is going to end up in the top. 5 minus 2 is 3, so there's 3 w's in the top. And I hope you can see at this point why the w's end up in the top, because there's more w's in the top than in the bottom. So these 2 w's are going to cancel out 2 w's up here, and the leftover w's are still going to be up here in the numerator. All right, so you're doing good. Now we go on to the division problems. Remember, with division problems, there's just one extra step. You have to change this to multiplication and flip the divisor. So why don't you try 64, and when you come back, we'll do it together. All right, we're back. So I changed the sign and flipped the divisor. So now we just multiply straight across. And a positive divided by a negative is a negative. And there you go. So the y's cancel out because they have the same power. So if you got that answer, good job. Try number 65, and when you come back, we'll do it together. All right, we're back. And we can divide the 3 and the 9 by 3 to get 1 and 3. This is a very similar problem than the one we had before. You can divide both the 4 and the 10 by 2 to get 2 and 5. So now 1 times 5 is 5. And 2 times 3 is 6. R to the 5th power times R to the 6th power is R to the 11th power. And we get G to the 9th. Only one G in the numerators. S to the 2nd times S to the 3rd is S to the 5th in the denominators. And G to the 2nd. And so we just have to reduce at that point. And let's see here. R's we already combined all those. We already combined all the S's. And the G's, that would be G to the 7th on top. So there we go. If you got that answer, good job. That was a long one. So let me just double check that. 6, 5. Everything looks correct. All right, on to number 66. So as you can see, we're almost done. If you've made it this far, I'm proud of you. This stuff is a little tedious. So attempt number 66, and when you come back, we'll do it together. So I flipped and changed the sign. So negative times a negative is a positive. 2 times 8 is 16. A to the 3rd. And we get C to the 5th, B to the 5th, and the denominator. So we just have to reduce at that point. B to the 3rd over B to the 5th. We're going to get 2 B's in the bottom multiplied together and 2 C's in the top multiplied together. So if you got that answer, good job. All right, 3 more problems to do. So go ahead and attempt 67, and when you're done, we'll come back and do it together. All right, we're back. And notice I didn't rewrite the parentheses on this fraction. I don't really need to do that. So now I know that I can divide 10 and 8 by 2 to get 4 and 5. So that helps a little bit. So negative 7 times 5 is negative 35. K to the 5th power. H to the 14th. Again, I'm just multiplying straight across in the numerators. And then P. And actually a negative times a negative is a positive, so I don't need that negative there. And 4 times 9 is 36. And P to the 6th power times K. So now I just have to reduce. And that should be our answer. So if you got that answer, good job. All right, on to number 68. Going to try number 68, and when you come back, we'll do it together. All right, we're back. I'm going to go ahead and write that over 1, that number that appears to be a whole number. And it becomes 1 over 2d squared. And then we know that 4 and 2 can both be divided by 2 to get 1 and 2. So we have 2 times 1 is 2. And d to the 5th. And then we have 7 times 1 is 7. D to the 2nd. And then we just have to reduce 2 over 7. And we have a d to the 3rd on the top. Again, you're just subtracting the powers. All right. So if you got that answer, good job. On to number 69. Attempt number 69, and when you're done, we'll do it together. All right, we're back. I'm going to write that number. It appears as a whole number. We're going to write it as over 1. Then flip the divisor, because we're doing division. All right, and we see we have a 3 and a 6. They have a common factor, so we can divide both of those by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Whoops. I don't need to cross out because I have highlighters. All right, and 2 times 4 is 8. And a negative times a positive is a negative. And 3 times 1 is 3. Or excuse me, 1 times 1 is 1. We don't need to write the 1 because we have a g in the bottom. And we have an r to the, we have to combine those r's to the 5th power, and g to the 5th power. And it looks like that's it. We just have to reduce those g's, so we have 7 minus 5 is 2, and there's more g's in the bottom than the top, so the g's end up in the bottom. We have 8r to the 8r to the 5th power in the top. So if you got that answer, good job. All right, so let's go to the homework. I'm proud of you if you made it through that. That was some challenging stuff. More tedious than anything else. Not really that difficult, but just tedious. Here's everything that we did today. If you want to use these pages to help you with your homework or to study for the test, take screenshots. Here's the first 2 pages. And the second 2 pages. And the 5th and 6th page. And the last page. So this is the homework. Get a screenshot of these first 2 pages. And a screenshot of the 3rd and 4th page. And a screenshot of these last 2 pages. Remember, your homework has to have 4 characteristics. It has to be complete, neat, correct, and in proper chronological order in your binder. And if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.